Hello, everyone. Welcome to our podcast. My name is Noam Dror. I run solution engineering at Hub Security, and I'm happy to be here. Ildiko.
Hi, my name is Ildiko. I am Senior Manager of Community and Ecosystem at the Open Infrastructure Foundation. I'm also a Community Manager for one of our top-level projects. It's called Starling X. It happens to be a fully integrated open source cloud platform for edge and IoT use cases. So I think that's a good upbeat to go and talk a bit more about edge.
Perfect. So some of the questions I'm being asked by many customers is, how do we deal with privacy at the edge? And maybe even a more basic question is, why there is private information at the edge? Why does it exist? And, what do you do with it? So Ildiko, you want to go first?
I think it is a great topic. And interestingly enough, just to look at it from the high level, bit of a holistic point of view, some people define edge as finally you're running your workload on your own infrastructure as opposed to running it in the cloud, which is somebody else's infrastructure. I always find this as an interesting definition for what edge is. But I think it also kind of shows it really well that the existence of edge is kind of partially because of privacy of data, that you don't want to move the data over somewhere else to be processed. And most of the people, I think, are thinking about the data concern from the perspective of bandwidth and what it takes to move larger amounts of data. But on the other hand, it's not just the bandwidth. Like if you think about efforts towards federation and just kind of thinking about sensitive data, sensitive because it belongs to a country, sensitive because it belongs to a person, like in healthcare. I personally would not want my health data to circulate the globe. So I think that it is a really important aspect of edge computing and how edge computing can help with keeping the data private and rather move the computing power to that data to be processed. And then obviously there are other kinds of use cases like the connected and self-driving cars. I really am hoping that no one will mess with my car and my car's data when it's driving to navigate itself on the road. So there are all kinds of really interesting and new use cases that are also emerging around this concept of the data stays locally and how we protect it and how we process and treat it. What do you think?
Yeah, I agree with what you said. So I think it really starts with what is the edge, right? Some people say edge is anything that is not public cloud, right? Some will say edge is really at the edge when it's close to an IoT or an end user. And the reason for it is really a variety of reasons. You said bandwidth, which is definitely correct. You have problem with how much data you can transfer to the cloud. Also, how costly it is to move the data to the cloud, especially when we talk about, I think the classic example of federated learning in AI is the Google keyboard, when every device, every Android device is doing its own AI, and you don't want to transfer all of the Android devices in the world AI or keyboard typing into one environment, even though it's possible, but it's very expensive and very heavy because just the amount of the devices, and therefore the AI is done on the device, and then just the models or even partial part of the models are going back into the cloud. So that avoids a lot of privacy issues as well there, but it also saves a lot on traffic. So that's one. So bandwidth and connectivity is important. Sometimes it's really around intermittent connectivities, right? If I need a service always up and running, let's say I'm a McDonald's, and I need to sell burgers, and it doesn't matter if I'm connected or not connected to the internet, I always need to sell burgers, but I need to know who my customer is. Then I need to have an edge in every restaurant. And it doesn't matter if the internet is up or down, I have to be able to work. So that's another important part. And as you said, there's also regulation issues, right? If there is a data residency issue where the data has to be in a specific place and cannot move to a different jurisdiction, then I have to put it somewhere. It doesn't have to be an edge, but it cannot be just anywhere. It needs to be in a specific place. Last but not least, I see more and more customers are telling me they need the edge because of performance. They don't have enough time to get so many hops to go all the way to the cloud in order to calculate something and go back into the edge. We see that more and more in industrial smart industries. You know, a good example is kind of smart glasses, where you want to maybe fix or build a jet engine, and you have smart glasses. Those beam the video recordings to a local server that does the AI and tells you what screws to fix in the jet engine. That just needs very fast performance, very fast response. You don't have time to go all the way to the cloud to do the AI and come back. So that requires an edge, and therefore, because of performance reasons, you want to have the data locally. And then why is it there? Because of a lot of reasons, right? If we take the hamburger example, maybe you have a loyalty program and you need to know something about your customers. If it's healthcare and you do an MRI or an ultrasound or any kind of medical exam, that's PHI, that's patient healthcare information. So that is there on the edge. More and more we see cameras and AI for cameras, people falling, people fighting, fires, crowding. Now with COVID, people not wearing masks or not socially distancing. So that a lot of data is there about private people, and that definitely needs protection. So so there's a lot of private information at the edge. For many reasons, right? So that's kind of my my answer for that. So maybe the next phase is, how do we really manage that private information? What are kind of the tools out there to protect private information at the edge, or automate private information at the edge? What do you think, Ildiko?
I think it is partially probably still an emerging segment, as edge computing opened up a lot of challenges, new challenges, and not just new challenges, but it also kind of put existing challenges back into the spotlight because of all the scale and other implications. So I think on one hand, like how you provide storage at the edge is probably an important aspect to consider. And I've been participating in some discussions around this, but so far I saw a lot of kind of head scratches in terms of, yes, we probably need some storage, but it's not what people have been focusing on mainly. They are currently delivering the kind of the first phase of applications. And I think as the trials are moving forward and they are putting both infrastructure as well as edge applications in production, that's when probably the fine tuning will happen around these kind of aspects. But we definitely have been discussing different solutions in terms of how you store data at the edge. Do you store all the data on the device? Is there some kind of a still remote but much closer storage than the cloud itself to the edge device? Again, it is also different if you have a smarter IoT device, or you have a bigger mobile phone with bigger storage, or you happen to have one or two servers, or maybe a really small rack of servers. So all these different configurations of edge really determines what you can do. Obviously, there are methods in terms of how you encrypt the data. You can encrypt, images that are being sent out to the edge when you power on a device, just to make sure that all the configuration was not tampered with as a first step. But then again, how you handle where you store that data, how you transmit, you need to encrypt it end to end. I just saw a TV ad, I think it was for WhatsApp, that is about end-to-end encryption of that data and the messages that you send, just because anybody can access the data at any hop within the system. And when it comes to edge computing, I think we even need to think about physical security, because the edge devices are much more accessible by anybody for good or bad reasons and purposes. So even the physical protection of the devices becomes something that we just have to think about a little bit more. I mean, I have, like probably many of others, a banking application on my phone, and that sometimes really freaks me out.
Yeah, makes sense. So I definitely agree. Maybe it really starts with physical security, because when you're at the edge, it's not a data center with, trap doors that you have to pass the one and then you pass the second, with biometric authentication and all those cameras and the floating floor and, redundancy in air conditioning and all that. You don't have that at the edge, because you have so many different sites. And you have very little compute power there, right? It's not like a data center when you have, usually 2 data centers and all of your power is there. So you can invest in a lot of computing and a lot of security for that. You have very few servers usually in a room with a regular door, maybe it's locked, and that's it. So it starts with physical, and then you need to make sure that, whatever you have there can detect some changes. If someone is taking your servers away and all of your data is there, you need to know about it and be able to wipe it out. That's how it starts. But it really continues with showing, the problem of cybersecurity in general. The way that cybersecurity was evolved is around an unsecure environment. So we designed the internet and we designed computers without security in mind. And then security came later on as patches and perimeter around the computer environment, which is great for a data center, because you can, if you have 1,000 servers, so I'll add another 50 servers, 100 servers to protect the 1,000 servers, not a problem. But if you have only 3 servers in a server room, in a plant somewhere, or on a tower, you cannot add another 50 servers on top of those 3 servers to protect them. You don't have all those layers. And that's, I think, one of the challenges at the edge. So I think it needs to be looked at a little bit differently. There is different technologies out there to protect the edge. SASE is one. It really works on a network layer. How do we segment the network? How do we authenticate with the network? So that's a good progress, but it's still not enough. It doesn't really get into the applications and the data itself. So I think that's kind of an issue. And then for the data itself, how you protect it, there are different ways. I hear a lot in healthcare, for example, about anonymization or de-identification, or privacy enhancing techniques. Some people like to call it that way. It's a good way to get the data changed, so you won't be able to recognize the individuals within the data set. From my experience, it's not 100% proof. So there's a way to reverse de-identify data. It's enough for me to know something about those users, maybe a date of appearance, or the facilities you went to, or even the diagnostics you had. Maybe how many people have 5 different diseases and went to 5 different facilities in a year time frame. It's pretty easy to figure that out. And once you know that, you know everything about that patient. For example, if we talk about healthcare, so the identification is not always enough, even though it is one of the authorized techniques for sharing data in healthcare. And then encryption would be a good option, but encryption can be expensive, and encryption can be, it needs to be managed. And again, putting an HSM in every edge is an expensive thing. We talked about those different layers that you need to protect the data. It will be expensive, so it will be good to have some sort of an encryption mechanism in every edge location so you can protect your secrets, your keys, and then your keys will encrypt the data at rest, in transit, and maybe even in use. That would be good. So encryption is an important part. And then an evolving solution today that I don't know if it's still ready for the market or not, is called homomorphic encryption, which is really around how do I process data while it's encrypted already. So when you do encryption, you have to decrypt it in order to process it, and then you need to encrypt it again. But with homomorphic encryption, you process the data while it is encrypted. So you can do math functions on the data and figure out some insights out of it. And that's a great way because the data is never exposed that way. The problem with that is that it's very limited to what are the functions you can do in the data. That's one. And two is performance. It's still not performing well enough to deal with large amounts of data, of encrypted data. That takes a lot. It takes a lot of power, a lot of CPU power, and it's still not fast enough. So I think that's kind of in the emerging space in the security space for protecting privacy, and looking forward to see what happens with it.
That indeed sounds really interesting and exciting to me. I haven't got the chance to dig that deep into this segment, so it's really interesting to hear these new trends. And I think it will also be interesting to see whether this will trigger some more hardware related trends out on the edge, just as you say, to be able to support these kind of methods, because it has a higher computational power requirement and high performance requirements. And we talked about a few things like the automotive use case. I don't really have the luxury of waiting for the car to figure something out just because the whole data set is encrypted. And then, will it stop in the intersection? Will it not stop? We don't know because, the computational power wasn't there. Or another use case that I would go back to is you mentioned the industrial space, which is really coming in strong in terms of digitalizing the factory floors as well. More and more robots are doing the job on those factory floors, and time is really essential there. Everything is running in real time. You have to be able to stop or correct what the robot is doing if something went wrong, if a computation went wrong, or if someone was messing with the environment and the software or data that the robot has. And that all has to happen in real time, because otherwise it can be damaging to the hardware resources and the materials. But not just that, but also humans who happen to be around those robots to maintain them and make sure that everything goes well. So it can become a huge issue if your application and the software is not performing well because it doesn't have the access to the data that it should do. So I think there is definitely a long way to go to figure out where you can use these kind of methods and how to make them more performant and more efficient.
Makes sense. So talking about efficiency, I think maybe the next question is, what are an emerging security concerns at the edge as it relates to automation? Because there's a lot of automation, coming to the edge. What are kind of the security concerns that are out there and evolving, and what type of maybe solutions are trying to target those concerns?
I would have one example to mention, which I think kind of points towards a bigger area, like the latest Log4j vulnerability, which affects, well, a lot of people, a lot of organizations, really anyone who's running Java and trying to log anything on their system,
Right.
the Log4j vulnerability affects them. And what does it all have to do with Edge? Well, it's one thing to find these vulnerabilities, but once they are kind of opened up to the public, then probably even those who haven't tried to breach a system with that will do. So you have to be able to patch the system really fast once obviously the patch is available. And when it comes to edge computing, we talk about not just one edge site or one data center, we talk about tens, hundreds, or thousands of sites that can be affected by something like this. So you
Right.
have to be able to rely on automation when it comes to delivering those patches securely to the edge and apply them and make sure that your edge nodes, site, whatever you call it, device is operating 100% securely based on our latest knowledge at any given time. And I think that it's currently still in the works to address this kind of challenge, like how to deliver patches on a large scale. Like I mentioned, the Starting X project. Starting X is targeting the end-to-end infrastructure, so from core to the edge. Like it delivers you the components to build the central cloud, and then you can add edge sites on a larger scale. And for instance, one of the focus areas of the community is definitely security. And with that also how you bring scalability into security. So they just did a demo to show how they patch the edge sites on a bigger scale. And I really, really love that one. It is up on the project's website, startingx.io. And I think it just really shows how the tendency is moving towards how you automate already on the infrastructure layer, because that's really, the layer that is right on top of the hardware. And obviously there are measures that you can do with the hardware devices themselves, secure boot, TPM, what you do with the BIOS and firmware upgrades and all those kind of things, how you deliver those. And then the software layer on top, that is the second layer, where you have to be able to do all the required measures to provide the highest level of security and trust that is possible. And then obviously there is the application layer on top, which still has to address these kind of challenges on their level as well. What do you think?
That makes sense. You make a very good point. The first point you made is that because there are so many sites in the edge, you really need to automate any kind of update. And vulnerabilities is, I think, the majority. It's two things there are two main reasons for any kind of data breach. One is vulnerability. So you have a vulnerability that is being exploited, and the other one is privilege abuse. You have some sort of a stolen credential or privilege escalation. Those are the two main attacks that are happening in every computing system, at the edge and at the core or in the cloud. So vulnerability management is very important. Patch management is the best way to handle it. So I do see a lot of progress in that space. A lot of companies have interesting solutions to distribute updates, applications in different layers. And you talked about the layers. So it starts with the hardware layer, where you need to update the firmware of your hardware. Then you need to go to your OS layer and your hypervisor layers and virtualization layers, all the way to the applications layer. And Log4j was a great example, because no one anticipated that every Java-based application on earth is kind of using Log4j. And now you needed to go and patch everything. And The other problem is, each edge site might be a little bit different than the other. It's not like a data center that everything is, by default kind of a standard approach. They have a gold image, and that's the way everything looks like. Edge can be different because each edge might have a different application or a different equipment or a different version, and therefore you tend to see more legacy stuff at the edge. So I think we should also look at mitigating controls. For example, don't let your internal applications, internal servers go out to places you never heard of, right? If I know that my edge needs to talk only with specific things in the cloud or specific things in other sites, those are the only places they can go. They cannot go to a rogue LDAP server that is being deployed because of that log4j vulnerability. So that, that's one thing that can be done. The other thing is really to validate every incoming message that is coming to the edge. So for example, if you have a specific application, you know how the string of communication looks like, let's verify that this is the strings that gets into that edge and not anything else, because anything else would be an exploitation of a vulnerability that you might have not patched for yet, or it can be just a 0-day vulnerability, so there is no patch. There are vulnerabilities that there is no patch for them yet. We're still waiting for a patch, and you need to find mitigating controls to deal with those vulnerabilities. So that's very important. And then, as I said, the second part of it is privilege abuse. So you need to make sure that your privileged users are being protected, that you use multi-factor authentication, that you have full logging, that even with multi-factor authentication privileged users, you have different privileged users for every operation. And if you can deploy a two-man rule, that means that no one person can do one thing. You have to have always two people to do a critical operation. That's the best way to, avoid a privilege abuse, because it's double the trouble to hack two privileged users versus one privileged user, right? So that's I think key there. But yeah, definitely there's a lot to do in terms of addressing the threats into the edge space, and we discussed just a few of those.
Really just a few of them. Like I'm co-chairing the Open Infra Edge Computing Group. This is a working group where we talk about edge use cases that are concerning, that infrastructure software layer from requirements and challenges and problems perspective. And we have a couple of people participating from the telecom sector. And we were talking about aspects like obviously telcos have a lot of remote locations, all the cell towers on top of a mountain, in the middle of the city, somewhere in a rural area, and not all of them is easy to get to and send the person to fix anything if it's problematic. So the automation part obviously kicks in there. But the other things that we were talking about is what happens when you have to plug in a new device into the system. Like, is it a preference that the human being is doing some of the steps, and some of them mentioned more from the operator side that they actually do prefer the human being not doing anything else but plugging in the cable to the device and then don't touch it. Right. And have the automated processes take over from there. The device, checks in on the network and has all the encrypted images and all the steps in terms of setting up that image on the device on that particular location. So they are trying to remove as much of the human interaction with the device and infrastructure as possible. Because as you say, you either have two humans to make sure that they all have the good intentions and or you just really eliminate that step and rely on automation. But then again, how does the authentication happen? Multi-factor or not, all the role-based access control kinds of efforts, the secret management, and also you mentioned the logging and monitoring part. That is something that both Starting Acts as well as other projects in the space, in the open source space, are looking into, as much as I know, like how you monitor these devices efficiently and how you raise alarms and log the events again efficiently, just to make sure that if there's anything happened, you know about it right away and be able to act on any problem and challenge. And I think the massive scale of edge computing use cases is definitely putting a challenge on figuring out these aspects, because they were already kind of a bit of a question mark in large data centers as well. At least whatever conference I go to, monitoring and logging, there are always sessions and there are a lot of questions and not a lot of agreements in that area as far as I could see.
I agree. And funny that you say the human element. I just had a chat a month ago with a major player in the power generation space, right? So they do power stations and they have a lot of technology in there. And they actually told me, I was surprised. They told me their new concept is that to have no human power stations. They don't want any person to get into their power station because humans make mistakes and machines do not make mistakes. So it's funny that is this new concept where we say, yeah, we better do everything automated and make sure that the automation works versus having people that can make mistakes. So that's interesting. Maybe the last threat that I see emerging, but that will take a while, is the power of quantum computing, right? So the power of quantum computing can, in the future, and I read different articles, some say 5 years, some say 20 years. So somewhere between 5 to 20 years from now, if you have a quantum computer, you'll be able to decipher encrypted data. So the key exchange process. So if I want to talk to you in an encrypted way, I need to send you a key. You need to send me a key, and that process is sensitive to very high computing power. So once that power exists, any kind of recorded traffic that is being done right now. So we know that there are nation states that are recording the internet, right? And in a few years from now, those nation states that have the recording that are being done right now will be able to decipher a lot of the information that is going on. And that will affect the edge as well, because if the edge is holding a lot of information and sending a lot of aggregated information to the cloud, that would be a problem. So we need to start preparing for a post-quantum era. But I think that's a topic for a different discussion, right?
Yeah, I mean, although if you look at how the COVID challenges accelerated innovation in the IT sector and software space and automation and digitalization, then we might get there sooner than we think.
That is true. That is true. There's a lot of innovation happening right now.
Yeah, it is really exciting, and I would like to just shamelessly plug in a call to action to everyone who's watching us chatting about these exciting topics to look into the open source space as well. I know that there's a lot of proprietary things happening around in this space, but there are a couple of open source groups and communities who are also talking about edge computing, and not just talking about it, but writing the software for the infrastructure part, for the application management part, even some open source hardware design is happening these days, and the integration between all these layers. So we need everyone to come and participate and share your experience, knowledge, requirements, use cases, so we can also have a little bit of a collective mind about this and really speed up that innovation that is happening in this space, to be able to have access to all these new use cases, and not just the use cases and solutions, but also these use cases in a secure manner, because as we just talked about it, it is really, really important.
Makes sense. Sounds good. Okay, Ildiko, it was a pleasure having this little chat with you.
It was great. I really enjoyed this discussion, and I hope that we can have a follow-up soon to see where the industry got with all these topics. Thank you
Sounds
for
good.
having me.
Thank you so much. Take care.
Thanks. Bye.